Hi guys, welcome to my video today. So today is my lucky day. So I got a freelance project with some small company here in Kenya, and I'll be helping them build an internal tool to automate their processes. So the pain point they have is they use physical receipts, and they want to automate this. They want to send invoices to their clients and store them and build like version 1. We are just going to build a management system, and then in version 2 we are going to build an analytics system on top of it. So what this company does is so I'm doing this with their permission. I talked to them that I'll be documenting my journey on YouTube while building this for them, so they know I'm doing this. It's not like I'm exposing them or something. They also, one thing was that I should not put any identifiable information about them on these videos, so I will look out for that. And this is the version 1 of the database that I've designed. So this will evolve it through migrations and all that. So let me take you through. So our system will have users, and then it will be a role based permission system will be role based. So we will have user roles, and then we will have the roles. So as you can see, our tables, the software I'm using here is dbdiagram.io. I've designed the whole schema. This is how I start most of my project, because when you know how the underlying data will flow and all that, you kind of come up with and then you have, it becomes easier to build. So because let's say for example, now we know we will have an API to create a purchase order item, an invoice item, to create a payment request, generate the invoices. We'll have background workers that will generate these in PDF format. We will have them signed on the system, but from the scope of this that is coming in version 2, they just want to have a central place where all of their quotations, petty cash, invoices, payment requests are maintained. So I'm going to build this with a Golang backend, and it's going to be hosted most probably on AWS. The front end will be hosted on Cloudflare. I don't know if you know this site. Yeah, this is where the front end will be hosted, and the front end will have an admin panel and all that. So how did I get this first gig? I think just putting myself out there, telling everybody around me that I build software, that, and also telling them that I could build anything. Or don't what I did not do is say that I'm not a front end guy, but I did not tell them that I only build backends. I told them that I build whole systems. So we've signed contracts for this. I've talked to a front end developer who is going to build the front end for this. So when I'm finished with the APIs and all that, I will engage him, and then we will dig deep into building this. So today on this video, I just wanted to show you the database schema and share this news with you that I have my first freelance project, and then also scaffold the Golang application. It's going to be a Go monolith. So we are going to have a modular Go monolith for this, and if it grows or if it needs to handle a lot of things that the monolith becomes a bottleneck, it will be easier for us, or for me if I'll be the one maintaining it at that point, to break it down into microservices. So right now I think I will jump into my terminal and create scaffold the project. So what do I need? What will I call it? That is unidentifiable. So let me just say management system. So I'll cd into management system, and then I'm going to open Golang here. So how do I scaffold my Golang projects? Let me initialize go mode init. And then create a main.go file. From here, package main So after creating my main.go file, let me test if it's run. If it runs, and that, so what will I need? I will need a make file. So in my make file, for a simple start, I'll have run. So let me make that works. Now I'm going to break it down into modules. So one thing I will have is the API module, and then the DB module. And when you take a look at this, there are a lot of PDFs that we will be generating: invoices, quotations, purchase orders, and all that. So we are going to have background workers. So we are going to have something like that. We'll also have a utils directory where our utility functions will sit, and we will have a config package. So for We are going to use SQL C to generate types of code. So we'll have we'll put that command there. We also want to have a way of creating new migrations. So we are going to use Go Migrate for this. Yeah, so that will be our way of making new migration. Let's see. Name. Let's see if it works. Yeah, you see we have a migrations folder and then we have these migrations files. So I'm going to delete this for now. We've known that works. We are deleting these for now. So inside our database, as I mentioned, we are going to use SQL C. So we'll need a directory. Let's name it SQL C, and then our queries will sit. We'll also have a directories where we have our queries. So let's initialize SQL C. And then it will produce this YAML file, sqlc.yaml. So I have a version that I always use on all my Go projects. So let's say we run make SQL C, it will try. We don't have any queries. So what are we going to do with our schema on database db.io? We are going to export it, and we are going to export the SQL schema. So we have this management.sql schema. So what I can do is look for it on my downloads and then just copy it, and then I will paste it in our project. No, instead of copying it in our project, let me open it, and yeah, this is the generated migrations file. So I'm going to copy the contents of this, and then I'm going to create a new migration called the initial migration. So make new migration, name equals to initial migration, and then I'm going to copy and paste all that there, and let me format it well. Yeah, so with this I think our initial scaffold is coming along well. What we need is queries. So let's write a query to create users. So for us to do that, we will need an SQL file. Let's call it users.sql. And using SQL C syntax, we are going to insert name create user, which inserts one document in the database, which is a username, hashed password, then full name and their email. When we come here and see make SQL C, now I think we will be able to generate this for us. I don't know why rows.scan is not. Yeah, so we see there are dependencies. We can run go mod tidy on this to download the dependencies. So other queries that we will need on this while that is happening, we will need to delete a user. So when we do that and come and check here, we see our delete user query has been created for us. So what happens is we need to write tests for this generated code. User.sql dot test. So for this, for the tests, I want to use the test containers package for the database tests, so that we are writing what is called integration tests. So we will write these tests, and we will also include them to run on our CI/CD pipeline. So they're going to serve as our integration tests. So how are we going to achieve this? I think for that I will need a package called migration, and then inside my migrations folder I will write code I will write code that enables us to run migrations on any database. So how test containers work is you spin up a Docker container with the infra that you want installed. So it will spin up, run the migrations on that, and then run database tests on that particular database that will be created. And when these tests are done, we will destroy the database instance. So what do we need on our migration files? So we'll write a function to run db migrations. So let's call it run db. So what will our function take? It will take the migrations URL. So this is the files, migrations files, and then it will take the db source, and both of these will be strings, will be of type string. So I think I would love to log this when it starts. For the logging package, we will need to have 0log. Let me import it here on the top, at the top. So if we run make go mod tidy, so we will need some packages. Let's check the go migrate documentation. Let's see an example. We'll need these two. Will we really need them? No, yeah. Let me call it migrate so that it doesn't disappear on us. So we call m for migration and error equals to migrate.new, which will take the db source, migration URL, and the db source. If error is not equal to nil, we can log.fatal that, and then if this function returns an error. So if all that goes well, I think our migration will be okay. Then we return nil. So let's go mod tidy here. So I want to work on this and finish it before. I want to finish it in around 2 days. The version 1 of the API should be done so that I can provide the API endpoints to the front-end guy so that we work on this. I promised that I will deliver in 1 month, but I want to have the first prototype out in a span of 2 weeks so that we have the time to iterate and change it according to their liking. So with that, this is just a setup. We are setting up everything we'll need so that when we start writing code and start doing our when you're writing the code and then we start writing so that we move fast, everything works and we can validate tests and all that. So right now what I'm doing is I'm setting up the test containers so that we are able to run these tests. So what will we need? Inside here we'll need a store. Let me refactor that. We need a store. So what will this contain? It will be an interface. We will embed this query interface to it, and then we will add other methods because we want to be able to do transactions and stuff like that. We will add other methods to the store, and also this interface will help us switch between databases so that we can, any database or any storage that implements the interface, we can plug and play. So what are we going to have here? We are going to have the store type, which is an interface, and we are going to embed the query interface here so that we inherit all the methods created when we run. Let's look at, so when we ran SQL generate, we generated this function, this interface. This is the interface. Their implementations can be found here. You see, this is the implementation of the delete, and this is the implementation of the create. So we are going to embed that interface into our store struct, and then we are going to have now a struct that will be our SQL store. And inside our SQL store, we want to use connection pooling. So we will have something we will call a pool. Let's just call it connection pool. Of types, we are using pgx. So it will be pgx.pool. So it is. So then we'll have a function to create a new store. And yeah, We are almost done. So now how do we test? We are going to have a main.test file here. So what are we going to have in our main.test file? So our tester is going to be of type store interface. So we'll have all these queries in our tester, and then we are going to have test main, which will take testing.m. It returns nothing. I don't know. Let me see if we can have a function called m.cleanup. No, we only have m.run. So we are going to create an instance of testing.t. This one will help us clean up our tests, because let's see, we can run t.cleanup, so that we clean up everything. So we'll also need context, and that will be, we'll take from the context package .background, not context.context. It will give us a context, and now this is where we initialize our test containers. So we'll have Postgres container, or error will be equal to let me separate this like this so that we can see them clearly. So it will require context, and then let me copy this something from the documentation. So going back to test containers, let's look for Postgres. Oh, it's not clickable. Our modules, and then let's look for Postgres. In Go, you'll have to get that. And then this is what I copy pasted, and then I just added a test containers wait strategy, so that we don't start using the database before it is up. So when you start database, when you start a Postgres, there's always a log that is written stating that the system is ready to accept connection. So we are watching for that, and then after that we can now, our database can now be up. So we'll need, let's put in everything that we'll need here. Our wait package is getting deleted. Oh no, our test containers is getting deleted, so let's put it there. Yeah, and with that, and we are going to use require. So here we are going to require no error. Oh no. Why is it behaving like this? Cannot use type. Oh yeah, I'm going to have that there. And then now we'll write the cleanup function. So how are we going to clean this up? And then when all is well, we are going to create to get the database URI and error from our then we are going to require then we are going to create a connection pool. So we're going to check our migration files. So our migrations files are in this folder. So here we're going to have a relative path to that folder. We're going to name that migration URL, which equals to, it will be a string and it will take the form of file. And then we are going to go back to directories and then into the migrations folder. That is where our migrations files live. Then we are going to have error equals to And then we are going to pass in the migration URL and the URI of the DB source. And then we should require no error and who. And then now we assign the test store. Equals to new store, and then we give it the connection pool that we've created there, and we run and exist os.exit m dot run. So let's go to our makefile and test. Let's write our test. So we'll have a function to create random user. It will take t, which is a pointer to testing.t, and then it will return a db user and who. So what will we need? We'll need the arguments. Args equals to create user parameter. So here we'll have hashed password. All of them are strings. We will improve this with the GoFaker library. I don't know if I should do that just right now. Let me do that right now, so that if we do this every time we call this function and we'll find that a user with this username already exists in the database. Like for one test instance, we might call this more than once. So if we do this, we'll find that a user with this username already exists in the database. And one thing is, tests should be very independent. So let's say we are writing a function to create a user. We are testing create user. It should be independent of when we are writing a function to test delete user. If we do something like this, it will force us to hard code these values. So that's why the Faker library comes in really handy on this. So let's see, go Faker v4. So this one will have faker.name. We call faker.name on that. Let's just paste it here and call it faker for now. And then let's try and go mod tidy to bring it to our project. And then hashed password. I don't know if Faker has So faker.password, and then email will be faker.email, and then full name will be faker.firstname. So those are our arguments, and then we will check created user, error, will be what do we name our, this is the test store. Yeah, so it will be test to dot create user. We pass in, let's import the context package. Why is it unresolved? Let's see, what did we name it? Oh no. Then I think that is just an IDE error. Then we require no error, and then we require that the user is not empty. Now let me see, go mode tidy, if it will help. Let's see, and then we return created user. So we'll have func I don't know why. Let's see if we refactor this. Yeah, so it was how we named our file. So let's run the go test command. So this will be go test verbose cover everything. Then let's do make tests. Wow, no go files in. Okay, we are missing a dot there. Yeah, this is because of Docker. Let's start our Docker desktop. Docker is up. Let's run that again. Yeah, so As you can see here, we are creating an image with Alpine 16 Postgres. We are pulling all this and then we are running a migration. There is a fatal error. I will sort this. I don't want to bore you with this error resolution. So yeah, this is how I scaffold a project. So I think I will need one folder called tokens, and this is where my JWT implementation will reside, because signing and all that will require that. So thank you for tuning in. I will record a video when I'll be doing adding some functionalities on the database side, and also a brief one on just testing more functions after I have sort out the error we came across. That will be video version part 2. In the part 2, we will also implement our tokens and the config package, and then after that we'll start implementing the APIs. Thank you so much. If you found this useful, please give it a thumbs up. It helps other people discover this. So a very good learning point will be when we'll be implementing the background workers, because this is where we implement asynchronous API calls and all that. So thank you, and have a lovely day.